Now we're going to do some u substitution with some e's. So remember, the inside of the e is a good u. So I'm going to let u equal x cubed. So again, I'm going to suggest you rewrite it. So then this comes off to the side, right? So du will be 3x squared dx. So then I'm thinking about what I'm going to replace. So this will give me e to the u, and I'm looking to replace x squared dx. So that's 1/3 du is x squared dx. So that gets taken out, and 1/3 du gets put in. You could take the time to pull the 1/3 on the outside, and you remember the antiderivative of e to the u is e to the u. So you just put the x's back in, so you get e to the x cubed plus c. All right, so similar here, I'm going to let u equal the x to the 5th. Du will be 5x to the 4th dx. So if I take the time to rewrite this, so I'd have x to the 4th dx. This I'm going to have e to the u, and now I'm looking for x to the 4th dx. There it is. So 1/5 du is x to the 4th dx. So 1/5 du. All right, carry along the 1/5. And you know the antiderivative of e to the u is e to the u plus c, and then you put the x's back in. E to the x to the 5th plus c. Ooh, okay, here we go. Got a little bit of chain rule and derivatives and antiderivatives. So doing them both at the same time. So here we go. So this is our u. Okay, so when we take the derivative of 4, that's 0. What happens when we take the derivative of e to the 2x? It's e to the 2x times 2. Chain rule, right? Okay, so I'm going to take the time to pull this and rewrite it to the 1/2 power. And then I'm going to pull these over to the side here. So do I have something to replace e to the 2x dx with? I do. So I'm just going to move the 1/2 over to the other side. So let's put the u in here. So I have u to the 1/2. E to the 2x dx gets replaced with 1/2 du. So pull the 1/2 on the outside. So now I'm ready to increase the exponent. So I'd have u to the 3/2 times 2/3. So I'd get 1/3, 4 plus e to the 2x to the 3/2 power plus c. All right, a couple more here. Got some denominators going on. I'm going to go for the most inside function. I'm going to let u equal that root x. So you know that's 1/2 x to the negative 1/2. When you're taking the derivative, you decrease the exponent, right? Okay, so let's take the time to rewrite this. So this is the same thing as saying this, right? Okay, so I would put the u in, so I get e to the u. Now I've got to get this. Is that over here? It is. This negative exponent goes in the denominator, right? So this is the same thing as saying this. I just need to move this 1/2 over to the other side by multiplying by 2. Now I can take this out and put in 2 du. So 2 integral of e to the u du, and that gives me e to the u plus a c. So e to the root x plus a c. One more. Okay, so I'm going to take the time to rewrite this and put this in the numerator. So I'd have e to the 4x, and this will be 4 plus e to the 4x to the negative 1/3 power, right? Okay, oh, sorry, it's a very messy 4. All right, so let's let u equal 4 plus e to the 4x. You know, the derivative of 4 is 0. The derivative of this would give me 4 e to the 4x dx. All right, so I'm going to rewrite this so you can read it for 1. Okay, that's all to the negative 1/3. So I'm just moving this over here by the dx, right? So this is e to the 4x. Okay, this is my u. So I have u to the negative 1/3. I need to get rid of e to the 4x dx. I see it. You see it? Okay, so I'm going to replace this with 1/4 du. pull the 1/4 on the outside, and now I'm ready to take the antiderivative, which is increasing the exponent, right? So I'm going to add 1, and so I get 2/3 times 3/2 plus the c, so I get 3/8, and then put the u back in, 4 plus e to the 4x to the 2/3 power plus c.